Hello there, I'm going to just show you how to do curve fitting in Desmos. So here we go, let's get the data from here, cool coffee, and we highlight the data. Control C to copy that. We're going to go over to Desmos, and it's as simple as this. Add a table, Control V, paste it in. Okay. We didn't have to add the table then. There's our data. Thank you, Desmos. And all we have to do regression, let's say we want to do linear regression, is do this. So y1 is the variable. Regress against, there it is. Nope, that's not it. There it is. y1 regress against ax1 plus b, or we could say mx1 plus c. It doesn't really matter what you call those parameters. One list of data. Okay. Oh, it's x2, y2. Okay, that's because I created x1, y1. Here it is. Okay. So there's our linear model, and I'm just gonna copy that across. Hold on one second. I'm going to copy that across to my report over here. Okay, now this is where you have to copy your function in here, right? So there it is, and it's going to be slightly irritating. One second. Okay, so you've just got to insert that in there now. I'm going to cut that out. And we've got y equals, this is the actual function, let's call it f of x actually. F of x equals, I said insert equation, didn't I? So insert an equation, f of x equals, and we've got parameters. M is minus 1.456, so minus 1.456x, and then c is plus 165.2. 165.2. That is our linear function, our model function in linear form. Don't need that anymore. I'll teach you more about R and R squared in the future. This basically saying it's negative correlation, very strong negative correlation actually, and by negative correlation it means that the graph has a negative gradient. This is a good example of how having a very strong R value doesn't necessarily mean a good fitting model, because this data here doesn't look very linear to me. You can see these are too high, these are too low, these are too high, but we still get quite a high R value. Okay, so we won't worry about the R value just yet. We're going to use a different way of testing the model today. That way is called residuals. So this is our model function, and I'm just going to pause for a sec. So when we're trying to I was just noticing something. Desmos claims, now the residual is the vertical distance between the points on the scatter plot and the function itself. Okay, that's what the residuals are. We can use them to see how well the model fits the data. Obviously the lower the residuals, the better. Anyway, so what I did was you can calculate residuals in Desmos like this. So there's my linear function. Okay, that was the linear function which was given by the linear regression in Desmos. There it is. So what I did was enter that into Desmos. I just switched the x for x2, so therefore it gave me the values for the model when these are the x values. So these are basically predictions from the model in this column here. Now then I looked at the distance between the values from the model, the data set. These are the data set values in y2. These are the actual temperatures, and then the difference between the actual temperatures and the temperatures predicted by the model. y2 minus, and then the equation for the model. So these are the distances. However, slightly strangely, when I look in, oh no, that's okay, 14.8. I think I figured out what's going on. Yeah. So when x is 0, the residual is 14.8, and we can see here when x was 0, the residual was indeed 14.8. Yeah, okay, that was confusing me a bit because I had 0 at the bottom, so it was all a bit out of sync. But so that's how we get the residuals. Okay, we're basically looking for the distance between the model and the data. Okay, so it used to be pretty hard to, well, you had to use a spreadsheet to calculate those before, but now we can simply calculate those like this, just by clicking on them down here. Okay, so it's automatically plotted that residual values there, and you can see quite clearly, hopefully, that when the points on the scatter graph are a long way from the model, we have a high residual value when they're above. When the points are below, we have a negative residual value, and when they're very close to the line, we have an almost 0 value for the residual. Okay.